Yeah, so hello everyone and welcome to our webinar Apache Spark plus OpenAI for personalized banking services. My name is Pavan. I'm a developer advocate and I'll be your moderator today. One of my main jobs at SingleStore is to organize these webinars, demoing data and AI use cases and new tools and technologies. I post about our upcoming webinars every week, and I talk a lot about AI technologies and concepts. So feel free to connect with me on LinkedIn to stay in the loop. I'd also love to hear your feedback or ideas if you have on topics you'd love to see in our future sessions. So, okay, so talking about the future sessions, we have got several great new webinar sessions coming up over the next few days. On 17, that is tomorrow, we have Accelerate MongoDB apps to drive 100x faster analytics and AI. I'll share the links to these webinars in the chat box. And Thursday we have something on Kafka, powering real-time AI with streaming data. And next week on 22nd, we have hands-on with Versal AI SDK with generative UI. So if any of these topics sound interesting to you, then RSVP right now, and I hope to see you there. I'll put these links in the chat after my talk here. So, okay, back to today's topic. You are welcome to participate in the discussion throughout the session using the Zoom Q&A button that you see at the bottom of your console. We have an internal mission statement to try to answer 100% of our audience questions. Yeah, even if that means following up with via email. This has gotten increasingly difficult over time as we now have thousands of registrations for each webinar and sometimes hundreds of questions, but we are up for the challenge. So ask away your questions, but make sure you have logged in to the Zoom with your name and email address. Also, we would love for you to try out our today's technology that our speaker Akmal is going to show you. Anyone who tries it today, they'll be entering for a chance to win either brand new branded AirPods Pro or Meta's new Ray-Ban LLM smart glasses. Your choice. Simply click the link. I'll share the raffle link. It's msql.co/spark hyphen OpenAI hyphen raffle. I'll share that link and log in. We have a completely free share tier, and it's never been easier to sign up in 30 seconds. And please try it out. So let me introduce our speaker today. Akmal Chowdhury is our speaker today, and he's a senior technical evangelist at SingleStore with strong expertise in big data, machine learning, and AI. He's a prolific author and regular speaker at our weekly webinars on data and AI. Hey, Akmal, welcome. Now you have the floor open.
Great. Well, thank you, Pavan, and thank you all for joining today. Good morning, good afternoon, good evening. Let me just make sure I've got these Zoom controls sorted out. There we go. That should be okay. I noticed there's a Q&A. So Naveen is asking, is this a promotion webinar? I'm not sure what you mean there, Naveen. If you mean, are we offering some goodies and a raffle and a prize? Yes. So hopefully that answers the question. If not, please post again, okay? And we'll get back to you. Okay, so watch for the posts in the chat. Okay, so Pavan will post the various links that he's mentioned to forthcoming events as well as the links. So we'll go into a little bit more detail on that momentarily. Okay, so just a couple of words about SingleStore. Okay, so historically, the company has actually been around for some years. So it's originally started life 2011. Okay, there are various milestones along the way, as you can see here, through the years. And so I guess the two important ones here are that you can see the revenue has grown to 100 million annual recurring revenue here, ARR, as of 2024. Well, 100 million plus now. And that started to increase fairly dramatically here, okay, between 2017 and 2018. And the number of customers globally stands at over 350 now. And again, you can see that that started to grow fairly rapidly here between 2019 and 2020. And the list of investors down at the bottom there, you can see some well-known names and well-known companies. Okay, so architecturally and historically, I mean, the product started live as MemSQL, both the company and the product, focusing very much on OLTP and in-memory data processing, subsequently added support for columnar data and the ability to do analytics. And with this universal storage here, it can handle both of those processing requirements. Integrates very well with a variety of technologies. So in the past, we have done events covering Kafka, for example. Today, we're very much looking on Spark, but Hadoop, HDFS, S3, various cloud resources can be easily accessed. And I think what the animation here is designed to show is that this is pipeline, so ingesting in parallel at scale, okay? So can take in vast quantities of data from a variety of different sources. So we are a cloud-based technology data platform, and today I'm very much going to be using AWS, although you can also run Google Cloud and Microsoft Azure if you wish. You can run on-prem too, and momentarily I'll show you where you can get access to a license that will allow you to install a four-node version free of charge. Okay, so that is actually the full product. It's not limited or constrained in any way other than the fact that it's only 4 nodes. Okay, and then you can install that yourself, whether that's internally within your organization or externally in the cloud somewhere. We do have some customers actually run that as well. There's a Docker container as well if you're interested. Stored data types. So historically, obviously, relational is the strength of the product. That's where it came from. But there is, and we've covered this in previous webinars as well. So we've done geospatial, time series. There is a Lucene full text search engine. Excuse me. And we have JSON support that's been there for some time, although that's got even better with the development of SingleStore Kai for MongoDB. So if you are working with that database technology, or indeed any of these other document databases that use JSON, then transitioning across to SingleStore is quite easy. Last but not least, vectors. Okay, very popular topic these days. So keep in mind that vector support in SingleStore has actually been there since 2017. It's not something we just added recently because it's popular and hot in terms of technology and topic, but we haven't just been sitting on the fact that we offer vectors, but we've improved upon the offering earlier this year. Okay, so there's a dedicated vector type. In fact, I'll show you a little bit of that today. There isn't time to go into too much detail simply because we have much more to cover in terms of Spark, but that's a topic we've covered a lot in previous webinars. And then finally, just to wrap up, real-time decisions, AI apps, dynamic experiences, ad hoc queries. There is a built-in SQL editor. Dashboards. If you are using technologies such as Tableau, for example, or whatever is your favorite tool for building analytics and visualizations, I use Metabase, free open source version, simply because it's very, very easy to use. Within a couple of minutes, you can be creating pie charts, bar graphs, and so on, and looking at the data. In fact, I will probably be using that on Thursday when I do the Kafka event. So all in all, as you can see, quite a wide range of capabilities and features. And so it is no longer just a database management system, but actually a data platform now, okay? Because we also integrate Jupyter notebooks, which I'm going to show you today. All right. So a variety of ways that you can do machine learning with SingleStore. Today, we're very much focused around Spark, which is a technology we mentioned from time to time in webinars, but haven't really covered a lot in depth, I would say. We work well with Python and machine learning libraries, scikit-learn, for example. And our notebook environment, although it's very much configured around Python, SQL, and Markdown, you can actually run R language as well. So if you're an R user, that's possible too. I've actually written a Medium article showing how to do that. Vector functions, okay. So as I said before, that support has been there since 2017. Dot product, Euclidean distance are the two main functions out of the box. Others, such as cosine similarity, for example, you can easily code. If there's enough demand for other metrics, distance measures, I think we're open to the idea of adding those. But again, that's one of those issues for engineering and roadmap. A couple of other things that might help you as well is that SingleStore has this thing called Code Engine using WebAssembly. So if you are particularly in the machine learning data science space, I mean, there are libraries, code out there. And if you work in some languages such as Rust, C, C++, for example, you can package these algorithms up, write some code to do some kind of functionality, if you like, upload that into SingleStore as a UDF, and the database system will treat it as a UDF. And that runs in a separate space from the engine. So essentially, you can extend the capabilities of the core engine, ad infinitum, if you wish. And one of the examples that I've used in the past is to take some Rust code and using this thing here, VADA, valence-aware dictionary and sentiment reasoner, which is actually just doing some sentiment analysis on data. I've built that, uploaded it into the database system, run it over fairly large table, and it works perfectly well. Last but not least, OpenAI. Again, we're using that a little bit directly, a little bit indirectly today through LangChain. But this list, as I said, not exhaustive, okay? Just some of the ways that you can utilize machine learning with SingleStore. Okay, so banking in particular is the topic of our discussion today. Why? Well, it's Gen AI's impact in banking is going to be huge. $300 billion in additional value in banking and financial services. Okay, so this is according to McKinsey. So enormous potential there and great possibilities in terms of utilizing this technology. In fact, I was just talking to a gentleman a couple of hours ago. We were discussing, some of the aspects of, LLMs. Yes, they are great, but they have limitations. And I think currently some of those limitations outweigh the strengths, but it's getting better and better all the time. And so I think, we look ahead to the future, I think there's a lot more that this technology will be able to help us with. And certainly I use ChatGPT a lot but I use it as an aid, something to augment what I already do, not to replace it. Just some of the financial organizations that are using SingleStore. So we've got a number of tier 1 banks, for example, and you could see some well-known names in that list. All right, then. So let's move on to the topic of today's discussion then, Apache Spark and OpenAI. So if we take a look, then just summarize briefly the key characteristics of Spark. It's a distributed computing platform, okay? Good for processing, analyzing large-scale data sets. Unified engine, okay, because it can do a variety of things such as batch processing, interactive, stream, machine learning, and we'll be looking at a couple of those today. In-memory processing, iterative computations, interactive analytics, very useful for that. Fault tolerant, okay, part of the design of the system for distributed processing, that it can recover in case of failure. And it's got a rich ecosystem. So the technology has been around for a number of years now, and it's got great support in terms of libraries and tools, as well as being an open source, top-level open source project at the Apache Foundation. So all in all, a very useful technology for some large data processing problems. If we take a look at Spark versus OpenAI, well, they are kind of two different things. You know, it's different kind of domains, if you like, in terms of what they're trying to achieve. A Spark is a computing framework. OpenAI focuses much more on the advanced AI models. Spark functionalities, big data analytics, OpenAI's natural language understanding generation processing. Spark, highly scalable, large data sets, whereas OpenAI more on models that can process vast data sets. And then Spark has got lots of high-level APIs in multiple languages. Spark SQL, Python, PySpark, okay, you can work in R and so on. Whereas OpenAI's APIs or pre-trained models for download. And both have, you know, great communities as well. So you can see that there isn't really much overlap between them. They are complementary, I would say, not, you know, designed for different problems and use cases, but can be used together, which is what I'm trying to show you today. Now, you might think, well, okay, if you're doing kind of machine learning, why not use something like scikit-learn? That out of the box is super easy to use. Well, indeed. But keep in mind that Spark is designed for parallel processing and working over very, very large data sets, okay? Whereas if you compare it to scikit-learn, single node in-memory type computing, Spark works across distributed data, very good at that, whereas scikit-learn is not designed for that. Spark, again, wide range of functionalities, whereas scikit-learn, if we use it, we tend to use it very much in a focused way for machine learning problems. And both have got a range of APIs, although scikit-learn, you know, is simple and consistent, super easy to get started, very powerful as well. And then both, again, have very large communities and use bases. So in terms of where we could apply it, well, here's a couple of examples. I mean, there's more that you could do. For example, customer segmentation. But I thought I'd pick on two, which seem like fairly obvious candidates. So in terms of fraud detection, what would Spark be good at? Well, it would be good at processing and analyzing large volumes of transactional data to identify patterns. Okay, so I'll show you an example of that today. Whereas with OpenAI, we are much more focused on sort of content, if you like. So we could use things like unstructured data sources, such as text descriptions, customer communications, transaction notes, and do some analysis of that. I've kind of got an example, a simple example to show you. I struggled a little bit to find something specific from the banking space, but if you work in that space, I mean, I'm sure you've got use cases that you'll be able to apply this to. Very easy. And then loan prediction, Spark, very good at pre-processing and feature engineering on loan application data and for building machine learning models to predict loan approval. I've actually demoed that not so long ago. We did a webinar on that a little while back. And OpenAI can really assist in terms of analyze additional unstructured sources such as customer comments, loan application forms, and so on. I read somewhere, and I think this was a response from ChatGPT. It said that you could also use it to analyze things like social media comments. And I thought, well, that's kind of getting into dangerous territory, right? You're now utilizing what people post on the internet as a means to determine whether you want to give them a loan or not. So you have to follow these fair lending rules and laws as they may apply in certain geographies and countries around the world. And then you're getting into kind of muddy water there. But again, you can see that the two technologies are complementary. They can help each other. OpenAI can add value to what Spark is doing. Spark will allow you to do that data processing, and then OpenAI gives you the kind of extra elements on that. A bit like the icing on the cake, if you kind of, you know, want to think it that way. There's things that it can add additionally that Spark may not necessarily be able to do. Okay, so with that said, let's stop there a moment, okay, and let me switch. So I think, Arthur, you've got the links to the notebooks, I think. If you, I'm not keeping track of the chat, but I assume you're kindly able to post those into the chat if people want to follow along. But let me just set you up here before we go a little bit further. So if you took the image of the QR code or the link that Pavan has posted in terms of the trial for which you'll be entered into the draw, this is the sign up page that you'll see. You can see it's super simple. You can use Google, Microsoft, or enter your details in if you prefer to do it that way. The two key things that you get, which are pretty cool. This first one here is a free tier. Again, I'll show you how to provision that momentarily. Literally, it takes about a second. Okay. And then the second thing is if you need something with a bit more power, something a bit more customized, you do get some credits, $600 worth of credits, and that's useful. The example that I often give is that I joined the company, I mean, it's getting on for 3 years now, but around the time I joined, I created an account and the company gave me $500 in credits. I still have credits today, okay? So if you manage those carefully, shut down resources when you don't need them, it can actually last you a long time, okay? So once you've signed in, this is what you'll see, something like this. So you have on the left-hand side, you've got this kind of left nav with a set of controls. Okay, let me briefly show you these, and then we'll get into the notebook code as well. All right. So you've got start here. Okay, on the left-hand side, just under home page. Under it is this thing called gallery, as you can see here. I'm currently highlighting. That's very useful because we've got a wide range of examples of notebooks. So if I actually click that, you can see here that there are various examples. For example, if you want to know how to do a backup to your database to AWS S3, well, there's a notebook for that. And if you want to know how to ingest data from MongoDB to SingleStore using SQL commands, there's a notebook for that. Okay, so lots of great stuff there. Bootstrap your efforts, get you started very quickly. There's this thing here on the left-hand side. Again, can you see this? It says group. Okay, actually, I'm just thinking I might make this a little bit bigger. Zoom in, let's make the text slightly larger. So this thing here called group. Okay, so if we click on this, in order to use the notebooks, you need some compute resources, okay? So there's two ways you could do this. As I mentioned a few moments ago, you can go for the free tier. So as you can see, this is automatically currently selected here, start a workspace, okay? You can choose the workspace name. It gives you a default there. You're very welcome to customize that to your requirements. Currently, the only cloud provider on which we are running this is AWS. That may change, okay, for the other two main cloud providers that SingleStore supports. And then again, your choice of region here is limited as well currently. Again, that may change in the future. And then by default, you get a database as well. And again, you can change the database name here. So, I mean, one good thing might be just choose your initials, call it database, and then whatever project that you want to call it, something like this, maybe, as you can see. All right. And then all you need to do is just click this, create starter workspace. Okay. So let me show you that. And there you go. It's ready. So there are your compute resources. There's your database already created for you. Okay. And if you want connectivity details, just click on this thing here called connect. Here. Okay. And it will give you how to connect to a variety of, so SQL IDE, for example. All right. Now it's asking me to create a user and it's given me a password, which I can change, I think. Initially, you know, just remove this if I want. Okay, create my own password, but I'll take the default here. That's fine. And set the permissions to read and write, create user. And then here you can see it provides various useful bits of information here. So the host, okay, long URL, the port number, in this case, my username, password that I've set, okay, and the current database that I'm working with there. So, and if you want to access this externally from this environment, I believe you need a PEM file, which you can actually get from here. There's a link, certificate, okay? There, that will give you the what you need. All right, so that's a great way to get started. Now, equally, if you need something with a bit more, I mean, there are some limitations there, okay? So you get one database, 10 tables, some other limitations as well. But if you need something with a bit more power, let's go to group again. It's time, choose standard. Okay, and so here you can see quite a bit more choice in terms of your configuration and your choice of cloud provider, so on. So currently, let's see, let me find something physically closer to me. That's Europe West 2 in London. There's a couple of employee-only settings in this account. I'm sharing this with other colleagues. I'll just say next here. And then here you can see I can configure the actual compute resources as well. Okay, currently it's set to S00, which gives you 2 virtual CPUs, 16 gigabytes of RAM, and that will burn through 0.28 credits per hour. Okay, but you can change this. There you go. Okay, so depending on your requirements. Okay, so obviously the larger that you decide to make this, the more credits you're going to burn in terms of the resources. Okay, and then when you're ready, just click create workspace. Okay, so I won't do that, okay, because I have something running already, but that takes a couple of minutes. Okay, so I have to do a bit more work. All right. So those are the 2 main things. Okay, you do need some compute resources running before you can use notebooks. And for the notebooks, then again, in the left nav, if you take a look here, you'll see on the left-hand side here, there's something here called notebooks. Surprise, surprise. Okay, there's a plus sign next to it. Okay, so if you click on this, you can see that it's giving me a listing of some projects that I've already been working on. But in the top right here, okay, you've got new notebook, and you can see there's a couple of options there. Either create a new one, or you can import from file. So if you import from file, it will give you this wizard. You can here in the middle browse the files, okay, and then just locate the appropriate. Let's have a look. Desktop. Oh, I don't allow documents, downloads, and desktop here. As you can see, currently I have no notebooks saved there, but you will have the choice of loading it into your personal space or shared. Personal is fine. Okay, shared is useful if you're going to work with other colleagues on a project, but you need to give them the link as well and the permission to access that. Okay, it's not going to give them the ability to access that by default. All right, and so once you're ready, you just say import. I mean, you can see it's kind of ghosted out there, but once it's got something, you just import that. All right. Okay, so you've managed to create your account. You know how to create some compute resources, which you need for notebooks. For the notebooks, I've shown you how to import. And with the links that hopefully Pavan has shared in the chat, you can, if you wish, follow along, or you can try this later. And so what I've done is for today's code, I've actually split it into 3 parts because there was way too much for a single notebook, and it gets quite cumbersome to deal with that. So in this first part, what I've done is essentially just spent a little bit of time taking a couple of data sets. So here you can see I've created a database. So I've dropped it if it already exists. I've created it if it doesn't exist. Okay, and so make sure at the top you are pointing to the appropriate compute resources. Initially, you won't have a database. And for the free tier, you won't need this. Okay, because remember, it actually gives you a database. And so that's unnecessary here. I've taken some credit card data here. Okay, just read it into a pandas data frame. And this contains both fraudulent and valid transactions for credit card. It's from a larger data set. So this is the number of fraudulent transactions in the original data set was actually tiny. It's about 492, about 500. And it's absolutely dwarfed by the number of, accepted correct transactions. So I just basically took all the fraudulent transactions, sampled some of the correct transactions, put it into a CSV file, read that in here. And as you can see here, it gives me a little bit of information here. So I've got 0 is those that are good. They are correct. 1 are the fraudulent ones. So you can see it's a fairly small data set, but we are not going to be challenging Spark, and it's not going to raise a sweat. But your environment, you'll probably have much better compute resources than I will. And so you'll be able to utilize this at scale. And if we take a look at the data here for the CSV file, so you can see here that obviously someone's run some principal component analysis or something on the data. So we have no idea what 28 of these columns actually stand for. We do have some information on the amount. Okay, what is the actual amount of the transaction? And then we do obviously know the class, whether it's 0 or 1. So that's really what the data look like here. And then all I've simply done here is just take the opportunity to do a little bit of analysis, just take build a couple of simple plotly graphs here just to take a look at the distribution, see how much is the amount of the transaction. And you can see that certainly according to the sample that I've taken, the majority of these seem fairly small in value. Okay, most of them are down here. And so that kind of makes sense, because if you think about it, fraudsters, what do they tend to do? They tend to do things in small amounts so you don't notice, okay? It kind of slips in through all the other stuff that you're spending your credit card on. And therefore, that is something that probably is, that's reflected in the data there. And then again, in terms of the histogram here, we can see that the vast majority of these, again, they are fairly small in value. Oops, sorry. Just trying to be too clever there. There we are, this column here. So small amounts. Okay, and then all I've simply done then is taken that pandas data frame and written it to a SingleStore here. And it's done that in a table called credit card. And we've got 3265 rows. For the loan data, again, sourcing an external source of loan data here. It's, again, fairly small data set. And we've got a variety of fields here. We've got gender, whether you're married, whether you have dependents, your education level, your employment, your income, your co-applicant's income, how much you want to borrow, loan amount. How much is the term of the loan, your credit history, whether you have or you don't, where you live, the property area, and the loan status, either Y or N, whether you got the loan or you were refused. And we can see here that there are some missing values here. So here you can see under loan amount, we got a NaN. Okay, so first thing to do here, just remove those missing values, drop incomplete rows. And again, you can see fairly small data set. So if we take a look at the overall distribution, that there's 150 where loans were 152, sorry, where the loans were refused, 353 where they were approved. So again, very small data set. When Spark's going to raise a sweat dealing with that. I mean, you could use scikit-learn for this, right? But that's just an aside, right? The point here is to show you how you could still use Spark for this type of problem. And again, take the opportunity, do a little bit of analysis here, see what is the actual loan amount. And unsurprisingly, we see that the vast majority of the loan applications are reasonably small in value. Okay, whether they've been approved or declined. And again, if we take a distribution, you can see that it's very much skewed to the left-hand side there in terms of the loan amount. So fairly low amounts, unlikely to be for mortgages. Perhaps these might be white goods, for example, or smaller things. That kind of makes sense. Okay, and again, because we are dealing with categorical values up here, we got to do something about that. And so there's, I mean, property area, for example, is urban, rural, semi-urban, right? So we need to take some consideration of these. So just applying one encoding here to replace those. And then once we've done that, we write the data frame to SingleStore again. So now we have a table for loan data as well, which, as you can see, fairly small in size, 505 rows. So that takes care of the data prep for us. Okay, so we've taken some data from a couple of external sources, written them into two separate tables, all right? And then here's part two then, okay? So the next stage then is to say, well, okay, what we'd like to do is let's install Spark, which we can do within our environment here using the conda install. Okay, so the two things we need is Java through OpenJDK, and we need PySpark, okay? So that's what's happening there. Now, first time you run this, you'll get a huge list of packages that it's installed. I've rerun this, so actually it's just telling me that it's all there. All right, so it's slightly cleaner there in terms of output, but that's fine. We do need to access a couple of things. Okay, so we need some jar files because we want to talk to SingleStore. So we need a JDBC client, we need the Spark connector, and there's a couple of other things that we need, Apache Commons, and this is all that this is doing, which is downloading these jar files locally. Okay, there's another way we could do this using Maven, for example, but that's fine. I mean, this is a fairly simple example. And then basically, once it's all done, we create our Spark session here, as you can see. Now, it's giving me a couple of warnings there because it notices that I don't have Hadoop, native Hadoop library, but that's okay. Not required, doesn't matter. At this point then, we need to put some details in. So you recall that I showed you when you are configuring some compute, you need your host, okay, that long string, and you need your password. Okay, so here we're just entering those details. I've just modified this slightly, okay, so that it doesn't contain my connection string. And as you can see here, normally it's port 3306, okay? In the shared environment, you will find it will probably give you a different port number, okay? Simply because it's shared, right? You have to play well with everybody else in that environment. They can't see your database, you cannot see their database, but because it's a shared environment, you have to, you will be given a different port number. A little bit of configuration then to connect Spark to SingleStore, okay? A couple of parameters there. And then basically what we'll do then is utilize Spark's machine learning to take some of that data and process it. Just prior to that, we'll get LangChain ready here as well and enter our OpenAI key because we're going to use this in just a moment. I'll show you that. Okay, so the first problem then is looking at the fraud detection. So our task is to read the data from the database into Spark, which we can do very simply here. Okay. And then we just use the features and labels, all of this, vector assembler, standard stuff, nothing very complex here. Train test split, 70%, 30%, using a seed so that it is reproducible. And then once we've done that, just use Plotly to actually give us some insights into the model that it's created. So overall, it's done a pretty good job there. It's identified all the genuine ones, nearly all of them, okay? Got a few of them wrong there, you can see. Okay, they were genuine, but marked as fraudulent. It's type 1 error. For the other one, well, it's got most of the fraudulent ones correct as well. We did get a few of these. It's actually fraudulent, but marked as genuine. That's more serious, okay? Type 2 error. So, but as you can see, I hardly did any tuning, none at all. So for an initial attempt, that's not bad. Simply to build the model. And then we just print out some details there in terms of accuracy, precision, recall, and so on. Okay, so overall, that's not bad for a first attempt. Okay, now, what are the things that we can do? Remember that we talked about how Spark and OpenAI, LangChain, these technologies can be kind of complementary. So within LangChain, there is this ability to work with Spark data frames. And that's exactly what I've done here. So I've passed it the parameter for the data frame that I just created above. I've specified this temperature equals 0, so it's deterministic. Okay, I've opted for verbose equals false because in this particular instance, we don't need it, but that's fine. And then what we can do then, here's a couple of examples of how we could utilize Spark and OpenAI together in this case. I can ask natural language queries. So in this particular case, I've said, now, what's the average of the amount column? Yes, you could write this as Spark SQL, and you could write it as SQL within SingleStore if you want. The nice thing about this, though, is that it's pretty forgiving. If you mistype some of these words, it's smart enough to kind of figure out what it is you're asking. And then you can make that question much more complex. So that's given us an answer here, which is actually correct. I've verified this, okay, because based upon what we actually input earlier in the first notebook. And then here, again, simple question here. Find the number of rows where class equals 1. Fairly straightforward, nothing particularly challenging here. But again, it's given us the correct answer here. Remember from earlier discussion, it's 492. So in this particular way, this allows kind of free format, natural language access to Spark and allows us to query that just using English with typos if necessary. Works great, okay? That's awesome. Now, extend this to the second example for the loan approval. We're going to do something a little bit more complex here, okay? So here, again, we read the data in, okay, from the database into our Spark data frame. Same process as before, features and labels, vectors assembler, same kind of train test split, same seed, okay? Different problem, though, all right? And then again, just create a confusion matrix just to see how well we did. Well, we did pretty good. So 95 of these identified correctly, only one misclassified here. Not so good with the denied, the loan denial. So it's actually hasn't done so well here. Only 20 here. And then, this is type 2 error, much more serious here. There's 25 there. All right. Yeah. Again, this is kind of naive. It's just an initial run through. We need to go back and take a look at this. But if we look at the overall first sort of iteration of this model, it's pretty good. Okay, you can see the accuracy, precision, recall, all fairly decent numbers there, I would say. And then in this case, then what we can do is, given that the data in the first instance, in terms of the fraud detection, there's not a lot we can analyze there simply because most of the columns, for confidentiality reasons, haven't been exposed to us. We don't know what they mean, what they stand for. Whereas in the second case, we have a lot more information in terms of the structure and in terms of the values and the data that we actually have available. So one of the things that we can do there, similar sort of setup that we had with the previous agent that we created for the Spark. Here I've just increased a couple of values here, max iterations to 20 and the timeout to 60. Otherwise, this does tend to time out fairly quickly. It kind of gives up. And so what I've done, I've asked it a much more complex question here. I said, and I've given it a big hint as to what I wanted to do. I've said, without using the loan status column, basically don't look at the answer, build a loan approval model to determine if the following loan would be approved. And then I've given it some values. And these values actually exist in the table, okay? So I've got gender, applicant income, credit history, loan amount, property area. And so this is using the one-hot encoding which is what we stored in our database table and what we pulled back. And then, because interestingly, by default, it assumes that y equals 1 and n equals 0, I actually had to specifically tell it that loan status values are 0 is approved and 1 is denied, because that's how they are actually stored in this particular case. Otherwise, it gives me a wrong answer. So it kind of makes some assumptions, which is interesting. And then for this one, I've set verbose equals true because I kind of want to see what the agent actually does. And what it does, it gives me its thinking process here. So it looks at the data frame, looks at those values, looks at the column, and then there's a couple of things that it sees that are missing. And then it says to itself, okay, what I need to do is build a model. If I'm not allowed to look at the actual answer, I need to go away and figure out how to actually calculate this. And then you can see here, eventually it says, I know the final answer. And so the final answer is approved. Okay, there we go. And that's actually correct. And then similarly, what I've done is I've taken another example here. Okay, given it a similar kind of problem. Again, told it not to look at the answer, work through the data in the data frame, and then build a model. And again, give it the same information that, either the status is approved or denied, and it's 0 if it's approved, when it's denied, okay? And it comes back, and here, again, you can see that the processing here is slightly different. And I've run this actually multiple times, and sometimes I find that it does a lot more analysis in terms of it's outputting a lot more data as part of the process that it's using to build the model. So if you take a look at this with care, run it repeatedly, you do get different levels of output. And I'm sure there's a lot more investigation that's required here. And in this particular case, it tells me the answer is denied, which is actually correct as well. So I'm not sure if gender is an issue here. One of the things that I found using this particular data set in a previous webinar is that a gender seemed to be a very strong indicator of whether you're going to get accepted or not for a loan, which I think is preposterous. That's my view. But there we go. That's how the data are, and that seems to be the emphasis and the weighting that it has in the overall decision, is certainly as far as this is concerned. So here you can see Spark, awesome for doing the machine learning, building the model. As you can see, it's pretty naive, straightforward though. Initial kind of attempt, not bad. But with the integration that we have through LangChain, we can use OpenAI to kind of augment it. We can ask it interesting questions. We can pose questions in natural language. We can even ask it to build models for us, which is it's gone away and done through this. And if you follow the reasoning, it will show you how it's actually gone about performing that task. So pretty awesome, I would say. Very useful kind of combination of the two technologies being used together in a kind of a very positive way. All right. There we go. And last but not least, let's have a look at the third case here. So in this particular case, again, let me try and make this a bit bigger. Zoom in a bit. Okay, so this is part 3. So what I've done here is, again, because this is a separate notebook, I've had to, excuse me, install Spark again. In this case, I'm using OpenAI, but a slightly older version, 0.28, and then I had to ensure that LangChain OpenAI was uninstalled because otherwise there's a conflict. It doesn't like it. Okay, so again, we put in our OpenAI key. We do the standard things in terms of the jar files that we need to talk to SingleStore. We create our Spark session here. And we use this technology down here. Okay, so we are downloading this WordNet and tokenizers, okay, it's these sort of corpus, not sure what's the plural, and doing some tokenization. So what I want to do is I want to build some sentences that actually make sense. And where I tried to do this, okay, is that I tried to utilize some mechanisms, some libraries that would be relevant to banking data the quality of the output was not very good. And so I left it. I abandoned it. I thought there's no point because it's not giving me what I want. I'll just use it as text. You may have access to much finer and richer data than I have, and then you can utilize this in that context. But essentially what it's doing here, it's just building a set of sentences. It's writing that sentence into a file. Again, I'm keeping this fairly small scale. I'm just creating 5 files in a directory, and then just using this bash command here, I'm able to look at the content of these. And if I take a look at one of these, for example, it's got a fairly long one. It says here, oh, right, so that's making a bit of a mess of that, so it doesn't like that. Let me try this. Here we are. So this is the text that's being written into a file. It says wide-ranging light brown frog of moist North American woodlands, especially spruce. Okay, so I kind of grammatically correct, and it's not just a random bag of words, but it actually is something that makes sense. And so think about this as maybe if you were to take, say, a form that a customer has filled in and some text that they filled in as part of that process as well. Maybe you want to do some analysis of that text. And this could be one way that you could do it. Okay, there are others. Okay, but this is just to show you one possibility. And so I've generated a couple of random sort of sentences here. And again, just providing our connection details to SingleStore. So what we're going to do is we are going to create a table for these comments. And we are going to generate some embeddings here using OpenAI. Okay, so it's using the engine text embedding 3 small. Okay, it registers as a UDF, which Spark is going to use. So the reason for using this specifically rather than LangChain is because I had some issues in terms of serialization. I need to look into that. But what I found, it works this way, but not the other way I was doing it. Some pickle errors and things like that. It's something I will investigate, and if I can find the answer and fix it, I'll update this. But in the meantime, that's why here I'm using OpenAI specifically versus LangChain for the actual calling there in terms of the embedding. And then finally, all I'm doing here is using a very cool feature of Spark, which is just reading a stream of data. Okay, and so I pointed it to the directory where I've written those files with those sentences. I'm using this for each batch. So one by one, it will process each of those files. It will read in the content. It will generate an embedding with a call to OpenAI. And then it will write that embedding into SingleStore into that table. Okay, so that's all that's happening here. And I've specifically put a condition at the end here just to stop it. Otherwise, what happens is it just waits. Once it's finished processing all the file, it just sits there waiting and waiting. So in theory, what I could do is I could generate some more data, write it into that directory, and again, Spark would be able to pick it up. So Spark streaming there, awesome, very useful way to process the data. And then finally, just take a look at what we've actually got in the database itself, just using some SQL commands here. So you can see, I've just chopped off the columns there so that we've got some reasonable text to look at. So you've got the actual value, that's the text value, what's the actual name of the file that this resided in, and here's the OpenAI embedding that's been returned, that's been saved as part of that. And then one of the things I could do is, in this particular case, you saw me referencing the wide-ranging light brown frog. Well, one thing then you could do here is to actually initiate a search. In this particular case, my text string is fairly simple and straightforward. Okay, here. And I'm just generating an embedding from that. I'm using that as a query, and then I'm just interrogating the database to say, okay, find me something that matches this. What is the best thing, closest thing that you can find? And here, just using Euclidean distance. Okay. So it comes up, and the top value it gives me is obviously that sentence which we would have expected anyway. Okay, similarity. So, and then just stop Spark at the bottom there. So This mechanism shows you the power of Spark streaming. I mean, if you want to utilize it in this way, this is rather a cool feature. And it doesn't just have to be, doesn't have to be a directory, for example, that you're picking up some data from. Could be an external source, okay? Could be a live feed of some kind. And that could be data coming in. You are processing that as the data arrive. For example, you could generate some embeddings from that directly, save that in the database system, and there you've got, if you wish, both the original data as well as the embedding subsequently stored. And then because it's in the database system, it's long-term memory. That gives you the ability to interrogate this long after all of this is stopped and finished and gone, and the processing is complete. Okay, so there we go. We've got a couple of minutes there for questions. So let me just quickly go back to the slides. All right, just show you there. There we go. My favorite quote from Arthur C. Clarke: "Any sufficiently advanced technology is indistinguishable from magic." All right, awesome. There we go. Let me stop that there for the moment. Pavan, any questions, sir? Anything interesting that you've come across?
Akmal, I can jump in here. I joined late, but
Yeah.
I see there's a fair amount of questions. We only have 4 minutes, so we can try to get to as many as we can before announcing the raffle winner. But one very interesting one that just came in. What about the cost of embedding? Will this be huge for streaming data?
Yes, it could be. If you are going to call an external third-party source, and let's say it's a continuous stream, not something that's I mean, streaming comes in many different flavors. So you could have like short spurts of data arriving at fixed intervals of time, right? And that might be okay. If it's continuous streaming and data streaming in all the time, of course, you are using, if you're paying somebody else to generate those embeddings for you over time, that will run up a huge bill for you, I'm sure. The alternative there is to look at alternative technologies, open source, LLMs. There, you don't have to use an LLM, by the way. There are other ways to create these embeddings as well. That might be a solution. And maybe that's something that I could think about and work on for a future webinar. But great question. Yes. Yes, it would be expensive.
Awesome. Time. Here's one about, is SingleStore open source or is it paid? I'm gonna send the link to the pricing tiers, but I noticed we still haven't updated our pricing page to show the free tier. So Akmal, I wonder if you could just talk about those options for a minute.
So as I pointed out, the free tier is awesome. Starts immediately, literally 1 second to provision. As I said before, there is, let me just quickly show you this. Down here in the left-hand nav, there is this thing called self-managed licenses. You'll forgive me if I don't click on that because that will reveal the license for this particular account, but that will give you the license if you want to install the 4-node version free of charge anywhere you want, on-prem, in the cloud, whatever your environment you want to run that in, and that's the full product. However, I'd highly recommend doing the cloud, okay, simply because it's so easy to use.
Awesome. You're getting lots of compliments as always, Akmal. There's been some folks asking about engineering support. I just put a calendar link. If you want to chat with our solutions engineers on the phone, it's free. There's a calendar link there. You can also email us at hello@singlestore.com. There's a question here from Osama Rahim. Can we use OpenAI or ChatGPT 4 create dashboards with prompt-based dashboards?
Prompt-based dashboards, yes, you could. The flexibility that these LLMs give you, I mean, if you look at, people are using them for so many different things. One thing I forgot to show you was Squirrel, which is something that we have in our environment. So if you have a question about SQL, for example, you just ask it, you give it some information and it generates an answer for you. So something like that, very easy to do, literally. And you don't have to use ChatGPT or OpenAI. That can work extremely well with these open source LLMs as well, if you want to save money.
Awesome. I just put the link to SquirrelBot in the chat. Also, to your point, Akmal, we're actually doing a webinar in just a few weeks. I think it's called how to chat with your web analytics data or something like that. And it's basically the use case you described, being able to pose questions directly to your data. And we're going to do a real live use case with product data and website analytics data. So stay tuned for that. we really were over time here, so we're going to have to follow up with the rest of the folks by email. But let's wrap up really quickly and give out that raffle winner real quickly before I forget. Like we said at the intro, we've got several awesome webinars lined up. You can see the links on the screen here. Grab the QR code if you want, screenshot. I just put the links in the chat as well if you want to just click and register. Tomorrow is the Accelerate Mongo apps to drive 100x faster analytics and AI. Remember, that's that new Mongo API that we've got. Check it out, RSVP. And then Thursday, we've got Kafka Unleashed. Akmal will be back on stage to show how to power real-time AI with streaming data. And then next week, we're going to be doing the hands-on with Vercel AI SDK. I don't know if you've seen this. If you haven't, Google it. It's amazing. Vercel has this new generative UI. You can type to it and it will on the fly generate dashboards and generate user interfaces that can take action on your behalf, that can display the weather. It's so cool. We're going to do a session on it next week. Hopefully you RSVP and we'll see you at one of the upcoming sessions. The announcement, raffle today goes to Miguel Sanchez, software engineer at Santander Bank in Madrid. Congrats, Miguel. If that's not you, don't give up. We're going to give out one more, either AirPods or Meta Ray-Bans, your choice, by the end of the day to someone who has tried out Akmal's notebooks. We put it in the chat earlier. You can get it also via email. So once again, the way to sign up is just visiting that link. It's the Spark OpenAI raffle. Just log in. You can try the free trial or the free tier. And once you log into that link, you will be eligible, and give Akmal's notebooks a try. Thank you, Akmal, for an amazing presentation and demo. Thank you as well to Pavan for kicking us off today. And thank you to our audience for joining us. Have a great rest of your day, everyone. Bye-bye.
Bye-bye.